Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method, part 2. So we are going to see a differential equation solving using variation of parameters in another method. Okay, let's get going. Problem. Solve y double dash minus 2y dash plus 2y equal to e power x tan x, or d square minus 2d plus 2 into y equal to e power x tan x. This is an operator form of the given first equation. Okay, and also the given differential is in order 2. Given differential equation y double dash minus 2y dash plus 2y equal to e power x tan x. Now we can write y double dash as d square y by dx square minus 2 into dy by dx plus 2 into y equal to e power x tan x. Consider this equation as equation number 1. And we know the y double dash or y2 is nothing but d square y by dx square, whereas y double dash and y1 is nothing but dy by dx. Okay, now we can write d square y by dx square as capital D square y, which is in operator form. Using operator D, differential operator D, plus 2 into dy plus 2y equal to e power x tan x. Now take y common from all the three terms of LHS. Then d square minus 2d plus 2 into y equal to e power x tan x, which is in operator form. Say f of d into y equal to some function of x, where f of d is d square minus 2d plus 2 and r of x is e power x tan x. Okay, and the homogeneous equation of equation 2 is d square minus 2d plus 2 into y equal to 0, which is equation number 3. Let's now find the solution of equation 3 using auxiliary equation, and later we'll find the general solution of equation 2 and equation 1 using the solution of equation 3. Okay. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d square minus 2d plus 2, right? Let's replace differential operator by m, so that we'll get f of m equal to m square minus 2m plus 2. Now the auxiliary equation becomes m square minus 2m plus 2. Here we need to find the roots of this equation, so we'll use quadratic formula to find the roots. Minus b plus or minus square root of b square minus 4ac by 2a. Just compare this equation with general form of quadratic equation to find a, b and c. Okay, now substitute a, b, c values in this formula. We'll get minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into 1 into 2 by 2a. This is equals to 2 plus or minus square root of 4 minus 4 2s are 8 by 2. This is equals to 2 plus or minus square root of 4 minus 8 is minus 4 by 2. This is equals to 2 plus or minus, we can write minus 4 as minus 1 into 4 by 2. Again we'll split the square root of minus 1 into 4 as square root of minus 1 into square root of 4 by 2, since we know that square root of minus 1 is I and square root of 4 is 2. So we'll replace square root of minus 1 with I into 2 by 2. Now take 2 common from the numerator. You'll get 2 times 1 plus or minus I by 2. Here 2 gets cancelled and you'll get 1 plus or minus I. Therefore, m equal to 1 plus or minus I. The roots are complex conjugate. We know that when the roots are a plus or minus ib, that is a pair of complex conjugate, then the solution of homogeneous equation looks like y equal to e power ax into some constant into cos bx plus another constant into sin bx. I have used C3 and C4 instead of C1 and C2 because I wanted C1 and C2 to appear in the last general solution. Okay, fine. Now let's write the solution of homogeneous equation. The solution of homogeneous equation is given by y equal to, now compare 1 plus or minus I with a plus or minus ib. Then for a equal to 1 and b equal to 1, we'll get e power 1 into x into c3 cos bx plus c4 sin bx, right? Then y equal to e power x into c3 cos x plus c4 sin x. Therefore, y equal to e power x c3 cos x plus c4 sin x, or y equal to e power x c3 e power x cos x plus c4 e power x sin x, right? Let y equal to, now replace constants C3 and C4 by functions a and b, or functions of x a and b, or parameters C3 and C4 can be replaced by the functions a and b. Then we'll get y equal to a e power x cos x plus b e power x sin x, be the general solution of one or two, or 1 and 2. Okay, both are same. So here we need to find a and b. We'll find a and b using formulae. So we are going to use the formulae. A dash equals to minus v into r of x by u v1 minus vu1, and b dash equals to u into r of x by u v1 minus vu1. If you observe, we are having u v1 minus vu1 in both the formulae. So firstly we'll begin with u v1 minus vu1. Okay, so before heading to the formula, we'll just see what is u and what is v. Just compare this equation with y equal to au plus bv, or the solution of homogeneous equation with y equal to c3u plus c4v. Then we'll get u equal to e power x cos x and v equal to e power x sin x, right? And here a and b are functions of x. Now let's find u v1 minus vu1. We know that v1 is nothing but derivative of v with respect to x, and u1 is nothing but derivative of u with respect to x. This equals to u e power x cos x into v1, that is derivative of e power x sin x with respect to x minus v. e power x sin x into derivative of u e power x cos x is equals to e power x cos x into, here we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u, right? So consider e power x as u and sin x as v, then we'll get e power x, derivative of e power x with respect to x into sin x plus e power x into derivative of sin x with respect to x minus e power x sin x into derivative of e power x with respect to x into cos x plus e power x into derivative of cos x with respect to x is equals to e power x cos x into derivative of e power x with respect to x is e power x into sin x plus e power x into derivative of sin x with respect to x is cos x minus e power x sin x into derivative of e power x with respect to x is e power x into cos x plus e power x into derivative of cos x with respect to x is minus sin x. Okay, this becomes e power x cos x e power x cos x into e power x sin x is e power x whole square into sin x into cos x plus e power x into e power x whole square into cos x into cos x is cos square x minus e power x into e power x is e power x whole square into sin x cos x minus into plus minus, minus into minus plus. E power x into e power x is e power x whole square into sin x into sin x is sin square x, right? So here e power x whole square sin x cos x and minus e power x whole square sin x cos x gets cancelled, and we can write e power x whole square as e power 2x. See, we can write e power x whole square as e power x into e power x, right, which is equals to e power x plus x e power 2x. So you'll get e power 2x into cos square x plus e power 2x into sin square x. Now take e power x common from these two terms, or we can write it as e power 2x sin square x plus e power 2x into cos square x. Now take e power 2x common, then you'll get e power 2x times sin square x plus cos square x. Since we know that sin square theta plus cos square theta equal to 1, from this we'll get sin square x plus cos square x equals to 1. So let's replace the terms under brackets with 1. We'll get e power 2x. Therefore, uv1 minus vu1 equal to e power 2x. Now let's find a dash and b dash. We have a dash equals to minus v into r of x by uv1 minus v1. This is equals to minus v e power x sin x into r of x e power x tan x by uv1 minus vu1 is e power 2x. This is equals to minus e power x into e power x is e power 2x into sin x into tan x by e power x, e power 2x. Here e power 2x gets cancelled, we'll get minus sin x into tan x. We can write tan x as sin x by cos x, since tan theta equal to sin theta by cos theta. Right? This equals to minus sin x into sin x is sin square x by cos x. Since we know that sin square theta plus cos square theta equal to 1. Now take cos square theta to RHS, then we'll get sin square theta equal to 1 minus cos square theta. Let's replace sin square x with 1 minus cos square x. We'll get minus of 1 minus cos square x by cos x. In the numerator we are having two terms and in the denominator we are having one term. So we'll express it into two terms. We'll get minus of 1 by cos x minus cos square x by cos x. Then a dash equals to minus of reciprocal of cos theta is secant theta. So let's replace 1 by cos x with secant x minus, if we cancel 1 cos x, then we'll get cos x, which is equals to minus secant x plus cos x. Therefore, a dash equals to minus secant x plus cos x. So using this we'll find a. Let's now find b dash. We have b dash equals to u into r of x by uv1 minus vu1. This is equals to u e power x cos x into r of x e power x tan x by uv1 minus vu1 is e power 2x. E power x into e power x is e power 2x into cos x into tan x by e power 2x. Here e power 2x gets cancelled and we'll get cos x tan x. Let's replace tan x with sin x by cos x, so that cos x gets cancelled here. Then we'll get b dash equals to sin x. Right? So we got a dash and b dash. Let's find a and b. We have a dash equal to minus secant x plus cos x. Right? We know that a dash is derivative of a with respect to x equal to minus secant x plus cos x. Now let's separate the variables by taking dx to RHS. Then we'll get dA equal to minus secant x plus cos x into dx. Here the variables are separable, or we can write it as differential dA equal to minus secant x dx plus cos x dx. Let's perform integration. Integral dA equal to minus integral secant x dx plus integral cos x dx. Since we know that integral secant theta d theta equal to log mod secant theta plus tan theta, and integral cos theta d theta equal to sin theta, and integral d theta equal to theta. Then the above equation becomes integral dA a equal to minus integral secant x dx is log mod secant x plus tan x plus integral cos x dx is sin x plus integral constant is c1. Therefore a equal to minus log mod secant x plus tan x plus sin x plus C1. Okay, we got A. Let's now find B using B dash equals to sin x. We have B dash equals to sin x, right? And we can write B dash as derivative of B with respect to x. Now let's separate the variables. By taking differential dx to RHS, we'll get dB equal to sin x dx. Here the variables are separable. So let's perform integration. Integral dB equal to integral sin x dx. Since we know that integral d theta equal to theta and integral sin theta d theta equal to minus cos theta. So we'll get b equal to minus cos x plus integral constant c2. Therefore, b equal to minus cos x plus c2. So we got A and B here. Let's write the general solution using this formula or using equation y equal to A e power x cos x plus b e power x sin x. Therefore, the general solution is given by the general solution of 1 and 2 or 1 or 2 is given by y equal to A e power x cos x plus b e power x sin x. Substitute A and B here. We have A sin x minus log mod secant x plus tan x plus c1 into e power x cos x plus b minus cos x plus c2 into e power x sin x. This equals to e power x sin x cos x minus e power x cos x into log mod secant x plus tan x plus c1 e power x cos x plus into minus minus e power x sin x cos x plus c2 e power x sin x. So here plus e power x sin x cos x minus e power x sin x cos x gets cancelled and we'll get c1 e power x cos x plus c2 e power x sin x minus e power x cos x into log mod secant x plus tan x. Let's take e power x common from the first two terms. We'll get e power x times c1 cos x plus c2 sin x minus the last term remains the same. Okay, which is the required solution. This completes the problem. So we have seen part 2 in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.